Hi everyone. Today we will be learning how to build a basic full stack Dapp that will connect to a smart contract deployed on a local blockchain instance. The goal of this tutorial is to get you familiar with the tools that make up a full stack Dapp, which includes the blockchain and smart contracts, the deployment tools, and the libraries used to interact with the blockchain. We will do this by creating a simple app that will represent an election. In this example, we will create a simple form that will allow users to change the candidate name and store this result onto the blockchain. For this tutorial, we will not be using a framework like Truffle or Hardhat because frameworks are great to build a consistent Dapp, but requires a lot of setup and hides a lot of the complexities. When building a full-fledged Dapp, I'd strongly recommend using a framework. But for a simple tutorial, we can forego the complexities of setting up the environment and downloading the different library dependencies. It also allows us to learn about the underlying code and how it works. The basic building blocks of any Dapp consist of the following: a smart contract that defines the business logic of your application. In a traditional Web 2.0 application, this can be considered both the backend and the API layer. JavaScript and HTML source code that hosts the client-side logic of your application. The app will connect to the blockchain and interact with the smart contract. We'll be using the following tools in our tutorial: Web3.js, a JavaScript library that enables client-side applications to talk to a blockchain; MetaMask, a browser plugin that enables the browser to talk to the blockchain. This plugin is required because at this point in time, most common browsers do not support talking to the blockchain out of the box. Ganache, which is a local development blockchain to deploy and test your smart contracts for free. Follow the instructions in the page linked in the description to install Ganache CLI. And finally, Remix, a web-based smart contract IDE to help deploy your smart contracts onto the blockchain. Install MetaMask and Ganache CLI onto your local machine before continuing on to the next section. Before we deep dive into the main part of the tutorial, let's look at the project structure. These are the basic files that we will require before we can start developing our app. The Bootstrap library is a set of visual components that will make our user interface a bit more aesthetically pleasing. The Web3 library is used by our Dapp to communicate with the blockchain. It will provide us with a convenient way to talk to the smart contract. And finally, we have the index.base.html and index.completer.html. These two files represent the index.html file that we will be building. Completed represents the final form that the index.html file will take. And base is the one where if you want to run the tutorial from home, you can use index.base and copy and paste the code within. The index.html file also contains our front-end business logic. It will use Bootstrap and the Web3 libraries to connect and interact with the smart contract. Let's begin by copying the smart contract and pasting it into our Remix IDE. The smart contract can be found in contract/election.sol. Open the Remix IDE and let's create a new file called election.sol. So just click on the new file button there, type election.sol, and let's paste the smart contract inside. Now the Solidity file itself is a basic smart contract that captures a single candidate name on the blockchain. It has a constructor that defaults the candidate name to candidate1 and a function called setCandidate that changes the candidate's name. The candidate name itself is public, which allows anyone to read its values. So next, we'll be deploying the smart contract onto our local Harmony 1 blockchain instance running on Ganache. First, let's ensure that Ganache is running. We will need some information on the port that it is connected to. You can get this information by going to the Harmony 1 Ganache CLI and looking for the RPC server details. By default, this value is http://127.0.0.1, port 9800. Let's go back to the Remix provider. Go to Deploy and Run Transactions. Go to the environment and choose Web3 provider. Make sure the Web3 provider endpoint is the same as the Ganache CLI endpoint. Once you've successfully connected it, it will show you a list of configured Harmony 1 accounts, each with 101 that's been configured. Select one of the available accounts, go to Solidity Compiler to compile it. Once it's compiled, go back to the Deploy and Run Transactions tab, and then click the Deploy button. Once the smart contract has been deployed, it will appear in the Deployed Contract section of the UI. Expand the election contract and you will see two functions, a set candidate and a candidate name. Go ahead and click the candidate name. If we click the candidate name, you'll see that it returns candidate 1. Let's go ahead and change the candidate name to John Doe. Enter John Doe in the text field and then just click the Set Candidate button. At the bottom of the tab, you'll see that a transaction has occurred on the blockchain, and it will tell you some information about the specific transaction. Next, let's click the candidate name to make sure that John Doe in fact has been updated into our smart contract. Alright, now that we have our smart contract deployed, we can connect our Dapp to the blockchain. Open up the index.base.html and scroll to the script tags where it says Start Coding here. In this sample Dapp, we will create a place to hold the candidate name and a form to update the candidate name. In a real Dapp, you will typically use a framework like React, Angular, and have a lot more files. But for this specific example, we can put all our logic in the index.html file. First, let's put some standard code in place to allow you to connect to the blockchain. This boilerplate code will use the injected Web3 provider from the environment. And if that doesn't exist, we'll default to the localhost 8545. Next, we need to tell Web3 to use the default account, which has been injected into the environment. The account represents your connection to the blockchain and contains public and private key pairs to sign the transactions that you send. So once you have a connection to the blockchain and a default account configured, let's try to call the smart contract. To do this, we will create a Web3 contract object that will represent our on-chain smart contract. Web3.f.contract will handle the calls to the smart contract, but it will require two things, a smart contract ABI and a smart contract address. The ABI stands for Application Binary Interface and is a JSON object that defines the functions and parameters of the smart contract. Web3 uses this ABI to know exactly how to call the smart contract code from our Dapp. Now, to get the ABI, we go back to our Remix IDE, we go to the Solidity Compiler tab and click the ABI button inside the smart contract section. Paste the text in the ABI variable we just defined. This JSON object contains everything that Web3 needs to call the smart contract. We can collapse this JSON object to save some of the screen real estate. Next, let's go to the Deploy and Run tab inside the Remix IDE and click the Copy button in the Deployed Contract section. This will copy the contract address that has been deployed onto the blockchain. Paste the text into the address variable we just defined. This value represents the address of the smart contract we just deployed. We need this to be able to tell Web3 where on the blockchain the smart contract resides. Put quotes around the text as Web3 expects the address in a string format. Now that we have our Web3 configured and our representation of the contract defined, we can start to use it. So let's write some code to interact with the smart contract directly. First, we want to display the candidate name. If we open up our HTML file in the browser, we will see a blank candidate name. We want to dynamically retrieve the candidate name from the blockchain by calling the candidate name function. Web3 makes it easy to call our functions once we have configured the necessary parameters. We will get the candidate name and pass in a callback function to capture the output from the smart contract. This function takes an error and result that was returned. Once we have the candidate name, let's update the candidate name by getting the ID of the element we want to update and setting its HTML to the candidate name. If we go back to our browser and press refresh, we should see the candidate name appear. Alright, great. So now let's write some code to update the candidate name. When a user enters the candidate name and clicks the Add Candidate button, we should take the new name entered and update the smart contract with it. So let's hop back into our index.html file and add the code to do just that. First, we'll add a listener to the form object so that when the user clicks the Add Candidate button, we can pick up the submit event. Next, we'll call the prevent default function on the event object passed to our function, so our form doesn't get refreshed when the button is pressed. So then finally, we grab the new candidate name by getting the only input text field on the screen and calling the setCandidate function on the smart contract. Let's save the file and test out the changes. So let's refresh the browser and let's change the candidate name to Bob. Click the Add Candidate button and refresh the page. Now we can see the new candidate name. Let's change it to a few other things. Maybe we can change it to Alex. Alright, let's hop over to our Remix tab to make sure that the updates do indeed happen on the smart contract itself. So if you go back to the Deploy and Run tab and click the candidate name function, you should be able to see the new candidate name, Alex. Now, if we change that candidate name back to John Doe and click Set Candidate, we can now go back to our index.html file and see that it has indeed updated. So what we've just done is create a full stack Dapp that gives us the ability to read and write information onto the blockchain. We used Web3, Remix, and a local blockchain instance to read and update a smart contract. This is the very basic building blocks that you need to get started building more complex dApps. In this tutorial, we didn't use a framework because we wanted to simplify the setup and development. In practice, you look at using frameworks such as Truffle or Hardhat, which hides a lot of the Web3 interactions from you, including the account setup, the need to hard code the contract address inside the code, and the API. Truffle also gives you nice tools for deploying, testing, and changing the network environment. So the next step for this, after this tutorial, is to explore the Truffle framework and also consider extending our tutorial example so that you can add and update multiple candidates. At this point in time, the Dapp just changes the current candidate name. So you might want to look at adding an array and some logic around managing the indexes of the arrays and updating specific values in that array. So with that, we've reached the end of the tutorial. Thank you for your time, and we hope this has been an insightful experience.